Right now, automated bots are hammering login endpoints across the internet. Over 16,000 credential stuffing attacks every second. Authentication is not a feature. It is the first wall between your users and everyone who wants to be them. And that wall is only as strong as the method you choose. There are 8 authentication methods every modern developer must understand deeply. Basic Auth, Digest Auth, API keys, sessions and cookies, bearer tokens with JWTs, access and refresh tokens, OAuth 2.0, and OpenID Connect with single sign-on. Each one solves a completely different problem. So choosing the wrong one means your system is either insecure, unscalable, or both. Let's learn all 8. 2 concepts get confused constantly: authentication and authorization. Authentication answers one question: who are you? It verifies an identity, confirming you are who you claim to be. Authorization is an entirely separate question. What are you allowed to do? Knowing who someone is does not automatically tell you what they can access. Most security vulnerabilities live in that gap between the two. Every authentication system is built from 3 components: a credential, the secret only the real user knows or possesses; a verifier, the system that checks and validates that credential against a trusted store; and a session mechanism, the way the system remembers that verification happened, so the user doesn't have to reprove their identity on every single request. These 3 pieces are present in every method we are about to cover. Basic authentication, defined in RFC 7617, is the original HTTP authentication scheme from 1999. On every single request, the client sends an authorization header containing the username and password, joined by a colon, then encoded in base 64. The server decodes it, checks the credentials, and responds. The syntax is clean. The security is not. Base 64 is not encryption, it is encoding. Anyone who intercepts that header can decode your credentials in under a millisecond with any command line tool. Digest authentication was created specifically to fix Basic Auth's most dangerous flaw: the password traveling in plain text on every request. Instead, the server issues a challenge, a random string called a nonce. The client hashes the password together with that nonce and sends back the result. The server performs the same hash computation independently and compares. The actual password never leaves the client. A meaningful improvement, but Digest Auth relies on MD5, a hashing algorithm that has been cryptographically broken since 2004. And because the server needs to compute the same hash, it cannot use modern password storage algorithms like bcrypt or Argon2. Both methods are legacy. Avoid them in any new system. Basic and Digest are the past. Let's get to what actually runs the modern web. API keys are the standard primitive for machine-to-machine authentication, a long cryptographically random string, typically 32 to 64 characters, that uniquely identifies a client application or a specific user. You generate the key, store it in your secrets manager, and include it with every request in an authorization header, or less ideally, a query parameter. The server receives the key, looks it up in its database, retrieves the associated identity and permissions, and grants or denies access. API keys are powerful precisely because they are simple, easy to generate, easy to audit in logs, easy to rotate without requiring any client-side session management. They are the correct choice for server-to-server communication where you control both sides. The trade-off: API keys are long-lived secrets. If a key leaks, it remains valid until you explicitly revoke it, and they carry no inherent identity information about a human. A key tells the server which application is calling, not who the person behind it is. For human identity, you need something richer. Session-based authentication was the backbone of the web for 2 decades. The flow is elegant in its simplicity. You submit your credentials once, the server creates a session record in its database storing your user ID, permissions, and expiry time, then hands you back a session ID as a short-lived cookie. Your browser automatically sends that cookie on every subsequent request. The server looks up the session ID, finds your record, and grants access. After the initial login, no credentials travel over the wire at all. Sessions work beautifully when you have one server. The problem emerges at scale. Your session data lives on the server. If you have 10 servers behind a load balancer, all 10 need access to the same shared session store, typically a Redis cluster. Every single request requires a round trip to that store to validate the session. As your traffic grows, the session store becomes a potential bottleneck and a single point of failure. Sessions are fundamentally stateful by design. Statefulness is the enemy of horizontal scale. JSON Web Tokens, JWT, pronounced JWT, solve the statefulness problem at its root. Instead of storing session data on the server and issuing a lookup key to the client, the server encodes all the relevant identity data directly into a signed token and gives the entire token to the client. On subsequent requests, the client sends the token back. The server validates the cryptographic signature, no database lookup required, no shared state needed, just a secret key and mathematics. A JWT has 3 parts separated by dots. The header declares the token type and the signing algorithm, typically HMAC SHA-256 or RS-256 with asymmetric keys. The payload contains the claims, the user ID, name, roles, expiry timestamp, and any custom data your application needs. The signature is a cryptographic hash of the header and payload together, created using the server's secret key. If anyone modifies even a single character in the payload, changes an expiry date, elevates a role, the signature verification fails instantly. The token is tamper-evident by mathematical design. Bearer tokens use JWT as the credential format. The client sends the full token in the authorization header with the prefix bearer. The server splits it into its 3 parts, decodes the header and payload, which are merely base 64 encoded, then recomputes the expected signature and compares it to the one in the token. If they match and the expiry has not passed, access is granted, 0 database calls. This is why JWTs became the modern standard for REST APIs and single-page applications. They scale to any number of servers without a single byte of shared state. JWT tokens introduce a revocation problem that sessions don't have. Sessions are trivial to invalidate. Delete the record from the database, and the session ID becomes worthless immediately. JWT tokens are self-contained. There is no database record to delete. Once issued, a JWT is cryptographically valid until its expiry timestamp passes, even if the user logs out, changes their password, or their account is suspended. The solution to this is short expiry windows. Access tokens typically expire in 15 minutes to 1 hour. Refresh tokens solve the usability problem that short-lived access tokens create. A refresh token is a long-lived, opaque credential valid for days or weeks, stored securely by the client, typically in an HTTP cookie. When the access token expires, the client silently sends the refresh token to a dedicated token endpoint and receives a brand new access token in response without any interruption to the user's experience. To permanently revoke access, a logout, a password change, a compromised account, you invalidate the refresh token in the database. The short-lived access token expires naturally within minutes. And this pattern gives you the scalability of JWTs with controlled auditable revocation windows. OAuth 2.0, defined in RFC 6749, is not an authentication protocol. It is an authorization framework. It solves a specific, well-defined problem. How do you let a third-party application access your data on another service without ever giving that third party your password? The canonical example, you want a task management tool to read your Google Calendar events. OAuth 2.0 lets Google grant that tool limited, scoped access to your calendar, and you can revoke that grant at any time without the tool ever seeing your Google password. The OAuth 2.0 authorization code flow has 4 actors. You, the resource owner who holds the protected data, the client, the application requesting access, the authorization server which authenticates you and issues tokens, this is Google, GitHub, or your own Auth 0 tenant, and the resource server, the API holding your protected data. You click Authorize, you are redirected to the authorization server where you log in and approve specific scopes. The server issues a short-lived authorization code to the client exchanges that code plus its own client secret for an access token. The access token is used to call the resource server. Your credentials never touch the client application at any point in this flow. OpenID Connect, OIDC, is an identity layer built directly on top of OAuth 2.0. The distinction is critical. OAuth 2.0 answers, what can this application do on your behalf? OpenID Connect adds the answer to, who is this person? When the OAuth flow completes with OIDC enabled, the authorization server returns not just an access token, but also an ID token, a signed JWT containing verified identity claims, your name, email address, profile picture URL, a globally unique subject identifier, and the exact timestamp of your most recent authentication. This is what the Sign In with Google button actually delivers to the application. Single sign-on builds on OIDC by introducing an identity provider, an IDP, as the single authoritative source of truth for every user in an organization. Every tool your company uses, Slack, Jira, GitHub, Figma, Salesforce, delegates authentication entirely to the IDP. When you open any of these services, they check whether you have a valid IDP session. If yes, the IDP issues a token for that service without any login prompt at all. If no, you authenticate once at the IDP, and that session carries you into every other service. Security teams gain something invaluable: every user's access, every permission, every login event managed and audited in exactly one place. Let's place all 8 methods side by side. Basic Auth and Digest Auth are legacy protocols. Never use them in new systems. Basic transmits credentials on every request. Digest relies on MD5, which has been broken for 20 years. API keys are stateless and excellent for machine-to-machine and service-to-service communication. Sessions are the correct choice for traditional server-rendered applications where you fully control the infrastructure, and a shared session store is not a scaling concern. JWT bearer tokens are the modern standard for REST APIs and single-page applications, stateless, horizontally scalable, and 0 database lookups per request. The access plus refresh token pattern layers revocation control onto the JWT model without sacrificing user experience. OAuth 2.0 is the correct architecture for delegating access to third-party APIs. It solves the password sharing problem definitively. OpenID Connect adds verified human identity on top of OAuth, and SSO federates identity across an entire organization's tool stack with a single controlled login. The right method is always the one whose trust model matches your actual threat model. So, how do you rapidly map requirements to the right method? Connecting servers, API keys, traditional web apps, sessions, scalable single-page apps, JWT bearer, need revocation, add refresh tokens, third-party access, OAuth 2.0, internal enterprise identity, OIDC, and SSO. It's an exact science. Now let's lock it in. 8 authentication methods, 8 distinct trade-offs: basic and digest, legacy, never use in new systems, API keys, machine-to-machine, server-to-server, sessions, stateful apps with controlled infrastructure, JWT bearer, stateless scalable APIs and SPAs, access plus refresh tokens, revocable, short-lived credentials, OAuth 2.0, delegated authorization without sharing passwords, OpenID Connect, verified human identity on top of OAuth, SSO, one login every system in the organization. Authentication is not a feature you bolt on at the end of a project. It is the first architecture decision you make, and the one with the most permanent consequences.